Hi there, and welcome to the test review for sections 1.1 through 1.4 and sections 4.4 and 4.5. Just a reminder, you'll have a calculator for 1.1 through 1.4, but you will not have a calculator for the section test portion for 4.4 and 4.5. That'll be on a separate sheet of paper. You want to make sure that you're working hard, and I do believe that you can do fantastic on this section. Let's go ahead and look and see what we have here. This is just a reminder that you are definitely going to need to be using some colors. As I'm walking around checking notes, checking work, I'm seeing that you guys are not using the colors. You really need to be utilizing your colored pencils and ballpoint pens so that you can make sure that you are emphasizing the important things. So it's very, very important that you structure your notes the same way, the review should be structured, the bubbling should be the same, and you want to use colors so that things pop out at you. Now, the first thing you're going to want to do is head your paper test review 1.1 through 1.4, comma 4.4 through 4.5. As usual, you're going to need your name, date, and period, and then you're going to see 1.1 unit rate, and we have our first example here. All right, so for this problem, you're going to see, we're going to pretend that this is bags of dog food. You can get a 25-pound bag of dog food for $55.75, 10-pound bag for $23.90, 8-pound bag for $20.16, or a 40-pound bag for $87.20. Now, as you can see in these Best Buy problems, what we're looking for is the lowest cost per unit. So we're not looking for the lowest price, period. You could look at that in just a second and say, oh, the 8-pound bag is the least expensive. That's not what we're looking for. We're looking for the lowest cost per unit. So what that means, excuse me. So what that means is you have to find the unit rate for each one. So as you can see, I went ahead and did the first one here for you. You want to set it up as 55.75 over 25. And that's going to be the cost on top and the size on the bottom. And the reason you want the size on the bottom is because you want to have the cost per 1 pound. Then to get to that 1 pound, you have to divide the top and the bottom by 25. So you get $2.23 per 1 pound. Then if you do the next one, sorry, that's my dog, you get $2.39 per 1 pound. Then, stop it, Rocky. Then the next one is $20.16 over 8 pounds. Divide them both by 8, you get $2.52 per pound. And then finally, the last one, you get $2.18 per pound. So as you can see, when you look at the per pound cost, the lowest cost per unit is going to be the 40-pound bag. So that is going to be your answer for this problem. Make sure that you understand that when you're answering this question, the actual problem, your answer will be this, the 40-pound bag. It won't be $2.18 per 1 pound, unless, of course, it says which bag is the lowest cost or the best buy and how much is it per pound. All right, moving right along. Goodness. So the next section says 1.1 unit rate, find the unit rate. So now we've got a problem. It says 252 ounces of milk for 18 cats. So you're going to want to find out what that unit rate is per 1 cat. So just like we did before, you're going to want to go ahead and set that up as 252 ounces over 18 cats. And then you're going to divide the top and the bottom by 18 so that you can find out that it's going to be 14 ounces per 1 cat. Then you can just put a box around your answer. The next section is going to be on 1.2 complex fractions. I'm not going to spend a ton of time on this just because we did this and we were pretty successful with it, so I think you guys have a pretty good grasp on it. So let's go ahead and go through one problem now. For this problem, you have 1/2 divided by 7, and that's basically what that fraction bar means, if you recall, divided by 7. So now you're going to set that up as 1/2 divided by 7 over 1, because 7 and 7 over 1 are the same. And then you're going to do your keep, flip, change so that you can now divide the fraction, because to divide fractions, remember, you have to flip them, invert them, and then multiply them by their reciprocal. So now we're going to go ahead and do that, and we get 1/14, and then you want to just put a box around that because you multiply across the top. You get 1 times 1 is 1, and then 2 times 7 is 14. Now we're looking at 1.3. This was the convert rates section. This section we did struggle with a little bit, but I think by the end of it, you guys all did pretty well with it. So I'm going to go over a couple examples here. The first one says 12 meters per hour equals how many centimeters per minute. So this is going to be a double conversion because you're going from meters to centimeters and from hours to minutes. So now you're going to want to have your conversion bubble in the top right corner. Now remember, when you have your conversion bubble, it needs to cover all 4 pieces. meters, hours, centimeters, and minutes. So we have our first conversion from meters to centimeters, which is 1 meter equals 100 centimeters. And then we have our second conversion, which is 1 hour equals 60 minutes. Then you just want to put your bubble around it. I would like to emphasize here for just a moment that you do not do the conversion bubble after the fact. The conversion bubble should happen before you set any of your problem up. So now you want to set your problem up. You're going to set it up with the rate that you have been given, which is 12 meters per 1 hour. And then you can decide to get rid of the meters or the hours first. It doesn't matter. I chose to work with the meters. So 1 meter equals 100 centimeters. So I'm going to put the meter on bottom though, because remember I need to get rid of that meter. So in order to cross simplify it, it has to be on the bottom. So we're going to go ahead and do that. Now we have 1 hour is going to be 60 minutes. And so now we can cross out our hours just like this. And now as you recall, the next step is going to be to rewrite the problem with just the numbers and the only remaining units. So you have 12 times 100 times 1 centimeter, 1 times 1 times 60 minutes. So now we're going to go ahead and just do that multiplication. So we get 1200 centimeters over 60 minutes. And this is fantastic, but unfortunately we need to know how many centimeters per 1 minute. So don't forget that very last step is going to be to divide the top and the bottom by 60 so that you can get 20 centimeters per 1 minute. Now you're looking at the next problem for convert rates, 1.3. Tim walks 2½ miles in 45 minutes. What is his walking pace in miles per hour? So the first thing you want to notice is that miles and miles are going to stay the same. So if you notice miles and miles. So you're only going to need one conversion. So that conversion is going to have to be between minutes and hours. Now don't think just because you have one conversion that it's going to be easy, because this is going to be a more complex problem. So first you want to start with your 2½ miles per 45 minutes, like I've done here. And then you want to go ahead and change that into an improper fraction. The 2½ miles needs to become 5/2 miles per 45 minutes. So now you have the 5/2 miles per 45 minutes, and you can actually start your conversion, which we hadn't done yet. So now we can say, okay, 1 hour is going to have 60 minutes in it. So now we're going to cross simplify the minutes, and then we are left with miles per hour, which is what we need. But now we need to do 5/2 times 60 over 45. So what we're going to do is go ahead and cross simplify that 2 and 60. And then we're going to be left with 5 times 30, which is 150 miles per 45 hours. I know that sounds crazy, but remember you have to divide out that 45 on the bottom, and then you get your final answer, which will be 3.3 miles per 1 hour. And you want to make sure that you remember the bar notation if your problem actually needs it. This one did, because it kept going and going and going forever. I would also accept 3 1/3 for that particular answer, but 3.33 works just fine. Now you're going to be looking at proportional reason in 1.4. I'm only going to do one example on this because this section was pretty easy for us, and so I want to make sure to spend the time on the sections that were a little bit more challenging. So as you can see, it says determine if the situation represents a proportional relationship, then explain your reasoning. So the earnings are on top, $5, $15, and $25, and the time is on the bottom, 1, 3, and 5 hours. So the thing that you need to do is you need to first set them up as ratios and simplify them. And as you can see, I've done that here, and all of the ratios simplify to 5. So my explain, which is going to be very important, because remember these are usually worth 2 or 3 points just for the explanation, is going to say yes, the relationship between earnings and time worked is proportional because all ratios simplify to 5. So I'm going to underline a couple things that are going to be super, super important here. So the yes is important, and then the relationship between, I need both of the things that are in the box, earnings and time worked is proportional, so it needs to say it is or it is not proportional, and then you need to have because, so because all ratios simplify to 5. So these are all the things that you're going to need for a correct explanation. Now we're going to look at section 4.4, add or subtract unlike fractions. Please ignore Rocky, he is in a very playful mood today. So the first problem that we have here is 5/6 minus -3/4. Just a reminder, you won't have a calculator for this section. So the first thing that I've done is set it up vertical, and I've done it that way so that it's a little easier for me to change the denominator. Because as we said before you can actually add or subtract these, you have to have a common denominator. So 6 and 4 are going to have a common denominator of 12. So we're going to go ahead and set that up and change the numbers just like I've done here. 4 times 3 is 12, so 3 times 3 is 9, and so on. Once I have the numbers that they're going to be changed into, I'm going to set the problem up horizontal again. And the reason I'm doing that is so that I can apply the integer rules for keep, change, change. Because if you notice, this is subtracting a negative. So it's going to be important that you take 10 twelfths plus 9 twelfths equals 19 twelfths. So now you have 1 and 7 twelfths. So now you want to make sure that you change that back into a mixed number because you have 19 twelfths. So that's going to be 1 and 7 twelfths, and you're going to put a box around your answer. All right, so now you're going to be looking again at section 4.4, add and subtract unlike fractions. I wanted to include a whole number problem because I know we struggled with these a little bit when we went through this section. So the first thing you're going to want to do is set the problem up vertically again so that you can change the problem. Now, I know that this looks a little weird to you, the 4 and 4 fourths, but you want to look at the fraction first. Notice it's cut into fourths. So now you can apply that to your whole number and say, okay, 4 fourths, which would still be 1. If I take that 1 and add it to 4, then I have 5. So all you've done is just regroup. So now you can just subtract the 4 minus 1, and that will give you 3. So now you are left with 3 fourths, and then the 4 is right there. So 4 and 3 fourths is your answer. Just a quick reminder on that one. Then we have add and subtract mixed numbers. This one we've been working on for the last couple days, so you guys should be pretty good with these. So I'm not going to do too many of these examples. We have negative 16 and 1/9 plus 11 and 1/3. So I'm going to set it up again vertical so that I can change it into an improper fraction. So I went ahead and did that here, negative 145 over 9 plus 34 over 3. This is an addition problem, so it's not, actually, let me first change them so that they have a common denominator. So now, notice 9 is the denominator, so I really only had to change the bottom one. So now I've got negative 145 over 9 plus 102 over 9. So since I have them over the same denominator, I can just look at the top numbers as whole numbers. And since it's addition, I don't have to do any keep, change, change. I just find the difference and then take the one of the larger absolute value, which is going to leave me with negative 43 ninths, which will then simplify to negative 4 and 7 ninths. So work hard, win big. The only time success comes before work is in the dictionary. So hopefully you enjoyed this very short 12-minute review, and I'm sure that you're going to do wonderful tomorrow.